Welcome to EDU World Space.
One of the important heating mechanisms for a dust grain in space is the photoelectric effect, which deposits some energy into the grain itself. Now, the photoelectric effect is such that usually there is an electron released as long as the photon has enough energy, not only to free the electron, but to get it out of the material. And of course, it's the energy that gets deposited that creates the heat absorption in the dust grain. But we can write the relationship conservation of energy for the photoelectric effect in the following way. So this is really just conservation of energy. So we have the energy of the photon that comes in, does two things, potentially. It could just get totally absorbed and not do anything. Or if it does release electrons, it goes into the kinetic energy of the electron, but also into what's called the work function. And it depends what text you're using, but the work function can either be in volts or electron volts. Here I'll calculate it in electron volts. And if you needed the voltage, you could just simply drop the E and you would have the work function in volts. But we will use atomic units to calculate the energy of the photon, given that it is a ultraviolet ray of wavelength 100 nanometers. And we'll use the atomic cluster. HC is 1240 eV times nanometers. And we are told that the kinetic energy coming off is, let's see, this is 12.4 EVs, is 5 electron volts of kinetic energy. Okay, so let's put the energy of the photon, 12.4 electron volts, is equal to 5 electron volts of kinetic energy plus the work function. And this is not an unreasonable work function for releasing an electron. It usually is of the order of a few electron volts. And that's the case here as well. And like I said, if you wanted the work function in volts, some people prefer that, you would just simply drop the E